thank you for joining me once again. Lately, we've been talking a lot about solving quadratic equations, and today we're going to add another tool to be able to do that. We're going to be talking about completing the square, and we're going to start out with some simple ones when our a value equals 1. So remember in our y equals ax squared plus bx plus c, in this case, all of the numbers in front of the x squared are going to be 1. Now, later on, we're going to have some that are maybe 2 or 3 or some other numbers out front there. So there will be a few modifications that we'll do, maybe just slightly a little bit harder, but not too bad. So the first thing I want you to think about is if we have a plus b times a plus b, because think about we're completing the square, and so what we want is a perfect square trinomial here. And so we have a plus b times a plus b, and if you remember multiplying that out, we have a squared plus 2ab plus b squared. Well, if our a is a variable, just say x, it just becomes x squared plus 2bx plus b squared. So in our first example, what we're going to do is we're going to look at, if we don't know what number this is here, what number do we need to put in there to make this a perfect square trinomial? So find the value that completes the square and then rewrite it as a perfect square. So in example A, m squared plus 14m plus what makes this a perfect square? So since if we look up here, our number in front of our variable is 14. That's our 2b. 2b right here is 14 in this case. So if we want to find out what b is, this b, if we want to find out what b is, we can just say 14 equals 2b, and we can really easily find out what b is. Just divide both sides by 2, and we get b equals 7. And so to decide what number to put in here, notice this is b squared. So if we take the 7 that we know b is and square it, it becomes 49. So our perfect square trinomial becomes m squared plus 14m plus 49. So now to rewrite that as a perfect square, it becomes m plus 7 quantity squared. Remember, our a value is m in this case, and our b value was the 7. So a plus b quantity squared is m plus 7 quantity squared. Okay, so just as a quick shortcut to find that value that completes the square, take the b value from our ax squared plus bx plus c, take that b value there, divide it by 2, and square it. So again, from this example, 14 divided by 2 squared is equal to 49. Okay, so we're going to do one more of those. We have x squared plus 3x plus what number completes the square, and then rewrite it again. So again, find b over 2 quantity squared. So half of 3 over 2 squared. 3 over 2 squared, well, 3 squared is 9, and 2 squared is 4, so it becomes 9/4. So 9/4 is the value that completes the square. So now to rewrite that as a perfect square, it would be x squared plus 3x plus 9/4, but we want to write that in factored form here, so we're going to write it as x plus 3 quantity squared. Okay, so now we're going to move on to actually what it is to complete the square. And here are the steps to actually do that process. So if you follow these steps pretty carefully, I don't think completing the square should be too terribly difficult. So first off, and I'll show you some examples, and I'll label the steps so that you see what each of these means a little better. But the first thing we want to do is move any constants to the right side of the equation. So in x squared plus bx plus c, it's that plus c that we want to move to the other side of the equation, or to the right side in this case. Okay, next thing, we want to find that value that completes the square. So let's find b over 2 squared and add that value to both sides of the equation. Remember, if we add something to one side of an equation, we have to add it also to the other side so the equation stays balanced. Okay, now, third step, just like what we did in the previous examples, rewrite the left side as a perfect square. So that a plus b quantity squared in this case. Okay, now once we have that quantity squared, we can now, because remember what we're doing is solving, we can now take the square root of both sides of the equation. The only thing to remember here is when we take that square root, we want to remember the plus or minus on the right side. So from here on, it is basically solving quadratic equations using square roots, which we did a couple sections ago. Okay, so take the square root of both sides, solve for x by either adding or subtracting whatever is left over after the x, and then rewrite or simplify your answer as necessary. Okay, so let's look at a few examples of actually doing that so that you can see these steps being used. Okay, so example 2. Solve each equation by completing the square and simplify square roots when possible. So we're going to look at this one over on the right side here first. X squared minus 6x minus 40 equals 0. So remember that first step was add any constants over to the right side. So here, step 1, I have added 40 to both sides. When you do that, do leave a little bit of room here because remember, we're going to find that value that completes the square. And we're going to add it to both sides. So if you leave a little room here, you have that space in there to actually do that. Okay, so we end up with x squared minus 6x equals 40. So remember now, we want to find that value that completes the square. That's step 2. So find b over 2 squared. In this case, the b is negative 6. So negative 6 divided by 2 is negative 3. Negative 3 squared is positive 9. Okay, now, so we've added 9 to both sides. Now go ahead and rewrite this side as a perfect square. So the b value was 3, so it ends up being x minus 3, quantity squared, equals 40 plus 9, which is 49. Okay, now remember step 4 is we want to take the square root of both sides. So when we take the square root of both sides, remember the square root and the square cancel each other out, and you end up with just x minus 3 on this side. And over here, we have the square root of 49, which is plus or minus 7. Okay, so now, remember that last thing, add or subtract anything, which is this 3 over here. We want to get x by itself, so we want to add 3. So x equals 3 plus or minus 7. So I rewrote that as x equals 3 plus 7 or x equals 3 minus 7, and then solve each one of those separately. So here 3 plus 7 is 10, or 3 minus 7 is negative 4. Okay, so that's it. That is our 2 solutions. Now, notice these numbers come out fairly nice, so we could probably have factored this and ended up with the same solutions. But I want to start out with some easier examples of completing the square before we go on to some more complicated ones. Okay, so in this next example here, x squared minus 17x minus 6 equals negative 4. So remember that first step is we want to move any constants over to the right-hand side. So this minus 6 needs to move. So we add 6 to both sides. Always undo what's being done here. So add 6 to both sides. So we get x squared minus 17x equals positive 2. Okay, so now we need half of b squared. Okay, so half of negative 17, which is negative 17 over 2, squared, which is, and that really should be negative in there, sorry, but negative 17 over 2 squared is 289 over 4. Now, we can leave it as negative 17 over 2 squared here, because remember, when we factor that, really we just need that b term. So it's going to be x minus b, which is 17 over 2 squared. And over here, and I made a quick note here, 2 is the same as 8 over 4. So if we take 8 fourths plus 289 fourths, we get 297 fourths. So that's where this 297 fourths came from. Now, go ahead and take the square root of both sides. So square root. Remember the plus or minus. So it's x minus 17 quantity squared, and take the square root of that gives us x minus 17. And 297, I did show over to the side here, that is 9 times 33. The square root of 9 is 3. So we get 3 square root 33 over 2, because the square root of 4 is 2. Okay, so we have x minus 17 halves equals plus or minus 3 root 33 over 2. Add 17 halves to both sides, and we get 17 halves plus or minus 3 root 33 over 2, which we can rewrite as one fraction instead of two separate fractions. 17 plus or minus 3 root 33 over 2. That should be a plus or minus there. Okay, so that is two examples here. Let's go on to a third example real quick of this particular type. We have x squared plus 15x plus 97 equals 4. So remember, first step, we want to move the constant over. So subtract 97, that gives us negative 93 on the right side. Okay, and we need to find what completes the square here. So take half of b, which is the 15 over 2, and square it. So 15 over 2 squared I write on this side. And there is a reason I leave it as 15 over 2, because notice when we refactor that or rewrite it as a perfect square, it's just that 15 over 2. Okay, but on the other side, 15 over 2 squared is 225 over 4. And 93, negative 93, written as something over 4, well, if we find a common denominator and just multiply top and bottom by 4, we get negative 372 over 4. So that's where this negative 372 over 4 comes from. It's just negative 93 rewritten. Okay, now we can subtract these, or add them if you prefer to say it that way. Negative 372 over 4 plus 225 over 4 is negative 147 over 4. So when we go and take the square root of both sides, we get x plus 15 over 2 equals plus or minus. Now notice, since s is negative, we need I. We need to include I here. And negative 147 is negative 49 times 3. So I have written that as 7i root 3 over 2, because the square root of 4 is 2. And now subtract 15 halves from both sides. So if we subtract 15 halves from both sides, we have negative 15 halves plus or minus 7i root 3 over 2, which we can rewrite as one fraction once again. Negative 15 plus or minus 7i root 3 all over 2. Okay, and that is everything for that one. That one is complete. So when completing the square, if you just follow these 6 steps, really most of them should not be too terribly difficult, even when we get into imaginary numbers. The trickiest part probably is up here, finding that common denominator, which if you just multiply top and bottom by whatever this is, you've got it. Okay, so moving on, one final example that I need to show you here, and that is rewriting a quadratic equation in vertex form by completing the square. Okay, so the process is very similar. I think it's actually a little bit shorter. So if we have something like this, y equals x squared plus 6x plus 2. First thing that you want to do is rewrite it and leave a little space here, because we're going to complete the square with this stuff, and then we're going to have some other number over here. Okay, so rewrite it, and when we add whatever here, we also have to subtract the same thing, because we're working on the same side of the equal sign. So work on the right side of the equation only. And so here, if we take half of b, 6 divided by 2 is 3, 3 squared is 9. So we're adding 9 here, and we're subtracting 9 here. And notice what happens when we do that. By adding and subtracting 9, or the same number in here, we're not really changing the equation. We're essentially adding 0 to the equation. We're just changing how it looks a little bit. Okay, so if we take this and now factor this and just simplify this part, we end up with y equals x plus 3 quantity squared minus 7. So factor the perfect square and simplify from there. Okay, now if we needed, of course, to identify where the vertex is, remember it's y equals a times x minus h squared plus k. So our vertex would be at negative 3, negative 7. Remember, it's always opposite of that one. Okay, so that's really all there is to it. I'm trying to not take too long, so trying to keep it short. So hopefully that helps you out. If you have any questions, be sure to ask in class. Thank you very much for watching, and have a great night.